Hi, I'm Mariah. Welcome to the Utah Go user group. It's been a hot second since we've had a meeting, but we're glad you're all here. And we're grateful, super excited for our speaker, who has been telling me he would speak for months, but never found time until now. So we want to thank our sponsors as usual. Weave for providing the Meet with the recording feature, as well as somehow Nozzle sponsors us. You'll have to take it up with Derek Perkins how that sponsorship works. But that is exactly how it works. We are looking for speakers. If you have a talk about Go and you're interested in speaking, please message me or Clint, and we can get you a time. I'm particularly looking for next month. It would be the 2nd of March. We'd be happy to get you set up there. And yeah, I think that's it as far as announcements. I'll post a link in the chat for anyone who has not joined our Forge Utah Slack. We ask that if you have jobs, please post them in the jobs channel there, so that we can get those looked at, people can apply, and the things of that nature. And without further ado, I'm turning the time over to Jeff Martin, my friend from Weave, and he will be giving us our presentation today.
All right, thanks, Mariah. Yeah, thanks so much, Mariah, for organizing these. You do such a great job in making sure things run smoothly, and really appreciate you doing that. Okay, well, glad you could all make it today. I'm excited. Like Mariah said, she said a few months. She's being gracious. I think it's been like over a year that I agreed that I would do some sort of presentation at a Go meetup. And honestly, I love the Go community. And so, yeah, so super excited to be here with you today. So what we're going to be talking today is we're going to be talking about gRPC, REST, and Go. And I subtitled this, How to Write Web Services in Go Without Hating Your Life. And hopefully it's not that drastic. Hopefully you didn't step into Go and realize you made a horrible decision. Honestly, when I first started dabbling in Go like 5 years ago, I was not very pleased. I did not like vendoring my dependencies. There was lots of things that just did not sit well with me. And having come back to Go about 3 years ago, I feel much happier now in the Go community. And so I'll get started here. My name is Jeff. I'm a software engineer at Weave. And as I go throughout the presentation, there's like 4 main topics that I'm going to hit on. But if you have little questions throughout the talk, you know, let's chat. I know a lot of people have their cameras turned off, and it's a lot different in this setting, but I'm hopeful that we can still have some good discussion. So a little bit about me. So I've got 5 kids, as you can see here. Despite COVID, you can see he's wearing his mask, but still kind of sharing out of the same drink. So that may not be COVID friendly, but great kids, and you may even hear them in the background as we go throughout the presentation today. So about 15 years ago, I started writing Java, and enjoyed doing that for quite some time. But I found myself to where I felt like I was just a Spring developer, and I felt like I wasn't really coding anymore. So I really wanted to get out of Java, jumped over to Go, and have finally converted over fully to Go. I work at Weave now, and that's really the only backend language we support at Weave, which makes it a lot of fun. I felt like in a lot of companies I was at, I was kind of battling to kind of get Go introduced and to kind of write Go services, and it's nice to be at a company where it's fully embraced. So with that, writing web services really shouldn't be a painful thing. You can look at this meme and think, okay, your first day on the job, you're super excited, and then a month later, you're like, what did I step myself into? Like, this company has so many problems, so much tech debt, it's just gonna be a pain. and all of a sudden it's aged you like 50 years. So it shouldn't be that way. Writing code should be fun. Writing web services should be fun. That's why Go was written, was to have fun. And so I have an example here of a REST endpoint. It's a delete endpoint. And if I were to ask you guys, what status code do you expect to be returned by this? You can throw answers in the chat, or you can say them, whatever you want to do. But what status code would you expect to be returned after an item is successfully deleted from this products collection? Any takers? Okay, Kenneth says usually a 204. What else we got? 204, no content. Okay. 418, teapot. Okay. Okay, so it's 500 if Carson wrote the backend. I like it. Okay, I should have included that as an option. Okay. So really, it depends, right? You know, depending on who's writing the service, it'll probably return one code or another. Salesforce, for example, if you don't return a 200 from Salesforce, it thinks it failed if it's not exactly a 200 code, right? And like in this case, what if the resource has already been deleted, right? People have argued that should be a 404. Other people say that should be a 204 because we want to be nice to the front end. And so it's a little ambiguous. And likewise with error handling, right? If it's a good REST service, there'll be kind of consistent error formats and response bodies. And then naming as well, right? Should this be /product or /products? And in the world of REST, I mean, people get super into this, right? And you hear about the degrees of the glory of REST. And I don't think I ever reached the top degree of the glory of REST. I'm still working on that. But anyway, these contracts, as you can see, aren't always super well defined and aren't super rigorous. And so why gRPC? Well, some might say, well, that's what the engineers at my company do. And so I'm going to do REST because they do REST. And that's what they've always done. But we can do better than that. So one of the main benefits of REST, as we'll talk about, is, and really, in my mind, the top benefit is really, with gRPC, we have well-defined contracts, right? And then also we have code generation. We can generate code for both client and server. And then it's also much more performant due to the binary nature of it. And so gRPC supports lots of different languages, as you can see here. I even mentioned to my wife, who does Android development, you know, there's no reason you guys can't be making gRPC calls to the backend using Kotlin. So, so a lot of good things there. gRPC's come a long way. And quickly, we'll just look at a comparison. I think most folks on this call, I probably don't have to convince that gRPC is a good thing. You've probably been exposed to it if you're in the Go community. But one of the main strengths, like I said, is the contract. It's very strict, very well defined. The protocol is HTTP 2 and versus REST, which is typically over HTTP 1. And then the payload, right? We have a binary payload instead of this large JSON blob. And so that makes it more performant. Prescriptiveness, we have very strict typing. Like in JSON, we have numbers and booleans and strings, but we don't have really strict types like we do in gRPC. Streaming, bidirectional streaming can be super handy when you really need it. At a company I worked at a couple years ago, we had to transfer this huge matrix from one service to another. And so we used bidirectional streaming, and it was awesome. Browser support, generally speaking, this is kind of one of the things that's not so good about gRPC is there's not great browser support unless you're using something like gRPC Web. They both support TLS, and then client code generation, right? As we mentioned before, being able to generate server and client code is a huge benefit of gRPC. So I'm going to go through just a few basics because I know we have all sorts of skill levels on this call. Some people may not be super familiar with gRPC, which is kind of crucial for this talk. So the first thing you do when you create a gRPC-based web service is you're going to define your proto. And this is really your contract, right? This is your contract between client and server. And as you can see here, I'm mostly just going to focus on the server section. You'll define the name of your service, in this case, traffic. And then you'll define your RPC functions, right? So in this case, we have get travel time, which is the name of the function. Get travel time request, which is what we're passing into the function. And then the message being returned out is our get travel time reply. And so very basic, almost every gRPC function you see will look just like this, request reply. And then you'll see that within the request, we have numbered parameters, which is important for forwards compatibility. And then also, one thing I want to highlight here is gRPC supports these well-known types, right? And so what that means is we really have access to almost an unlimited number of types we can put into our contracts. In this case, it's a traffic service. We want to know how long it takes to get from point A to point B. And so instead of returning travel time in milliseconds, right, something that we're used to seeing, we can actually return a duration. And that way the client, they can then format that into milliseconds, minutes, hours, whatever they choose. So these well-known types are super handy, and you can see to use that, we have to import this definition from the Google protobuf library. So lots of great things about this. As you can see, right, it's a very strict contract, very well defined. It's very clear how you should interact with this service. The next step would be to generate client and server code, right? So we would take that proto and use the protalk command to then generate the client and server code based off of this proto definition. One thing about this is, one thing you'll find is developers often all run different versions of protalk on their machines, and this can cause problems because if you have different versions of protalk, you can get different code generated. And so if you bake that into Docker, then you could, as long as you're using the same version of the Docker image, then you'll get the same code generated. And so that's something that is generally preferable. And you can bake any of the tools you need to generate the code all into that same image. So after you generate your client and server code, you'll get something like this, right? So you'll have your client code here, which is basically just an interface. And then you can call into that interface after you instantiate the client. And then on the server side, you can register your gRPC server with the generated code. And in addition to that, you'll also get the structs that you need to pass in and out of these functions. So the request and the reply objects, you'll get those as well from the code generation. One thing that's cool that I don't think I put very many documents in my protos normally, but I noticed on the code generation, it actually took my comment from the proto and put it into the generated code too. So your comments come from the proto to the code generation. Okay, and then the last kind of part about the gRPC basics that I wanted to go over is just how would you implement this on the server side, right? So it's as easy as just implementing an interface, right? So in this case, we have this get travel time function that by default is not implemented. And then you just go and implement that function on the server side. In this case, we're just returning a static, 11 minutes. So in case you guys thought I actually implemented the backend, I didn't. It's just here for looks. And then same thing on the client side, right? If I want to make a request from one gRPC-based service to another, it's as simple as making a function call, right? So as soon as I've set up my client, I've given it the address I'm connecting to, I can then send it my payload and just make a function call, which is a lot more straightforward than most REST calls. And so we ask ourselves, okay, I love gRPC. My front-end engineers hate gRPC. They don't want anything to do with gRPC. And so oftentimes our front-end engineers may say this type of thing, I want a single payload that gives me exactly what I want. I don't care about all these microservices that you've written. And by the way, I'd rather have it be JSON. And then on the other hand, you have the backend engineers, right? Who basically say, well, I want really great performance out of my gRPC-based service. And I want microservices. And I don't really even want to see JavaScript. I consider that to be a toy language. And so you have kind of this dichotomy, right, between front end and back end. And it's often like these railroad tracks, right, where they just don't sync up. And you may be working in an organization too where gRPC is not, is not a thing, and you need to be the one to introduce that in your company. Well, some of the things I'll present today can help with that. If you think about architectures at companies, how they often evolve. Product comes to you and they say, okay, we need this traffic service. We need to be able to report travel times between two locations. And so you spin up this traffic service. And then they say, well, really, we also need like weather related information. And, we need that. That's going to take a lot of traffic. So that's going to have to scale separately from the traffic service. So we spin up another service and we call it the weather service. And then you talk to your front end guy and he's really like, I'm having to make 2 calls to the back end to get traffic data and weather data. Like, seriously, I have to make 2 calls? And you're like, okay, fine. I'll give you a BFF. Since you asked for it, I will give you a BFF, back end for front end. And so you write this aggregator service, which is this dashboard service that calls into the weather service, calls into the traffic service, combines the response, returns it back. And then your front end guy, he's happy. He only has to make 1 request to get both weather and traffic information. And then he says, but really, we also need a user service. And so before too long, you find yourself in this situation where you have all these services calling each other in this weird dependency graph that doesn't really make sense anymore. And you just did it because you had to get it done. And then you're like, okay, I'm going to refactor it. And you refactor it and it still kind of looks like crap. And so this I think has happened to all of us at some point in our careers. And so we can do better than this. And here's an example too. Honestly, we have code that's very similar to this at Weave today, and quite a bit of it actually, where you have this REST handler. It takes in the REST payload. It then converts it to a gRPC request, makes the gRPC request, and returns a response. And honestly, it's like, really? This is what we've come to? We have to write all this translation code to translate from one format to another, and it just feels like boilerplate, right? At the end of the day, you ask yourself, was that a good use of my time? I spent my time today writing code that translates code into other code to call some other service. It's like, and what tends to happen too is this gets out of date, right? We add another field to this, and it's like, we don't go back and update this because that service didn't need it. And all of a sudden there's these weird discrepancies, right? And so rather than kind of doing this translation of REST to gRPC and these type of things, the gRPC-gateway is a great solution for this. The marriage of gRPC and REST. And this isn't the only way to do this, but this is one way. The way I like to think about this is traffic patterns, right? So when we're doing kind of service-to-service network calls, it's really handy to do gRPC, right? We have these great contracts. It's performant. So if we're doing, basically once a call comes in through the Edge API, it should be service-to-service after that, right? There's no reason to be using any REST at that point. But we still need to expose REST for our clients, right? We still have the front-end users that very much want JSON, and they're very much used to working in that way. And we may have other teams in the organization that aren't using gRPC and that need to consume REST, right? And so that's how this north-south traffic ends up being HTTP1 and JSON, and then this east-west traffic naturally ends up being gRPC over HTTP2. to implement the REST gateway, and let me go back here just a second. So like in this context, like I've deployed this basically the same setup into Kubernetes before. And the way you typically do that is your reverse proxy here, your gRPC gateway, you would deploy that to Kubernetes as its own service, right? As its own set of pods that you can scale out as much as you need to. And it's just a reverse proxy. And so this reverse proxy code gets generated from your proto, right? And the way that happens is you first have to update your proto with any kind of HTTP endpoints that you want to add to your service. So in this case, we have this get travel time RPC call, and we want to convert that to a get request in REST with the path of traffic / travel time. The nice thing about this is it's part of your contract, right? The proto is your contract. And so even the REST annotations all end up as part of the contract. And the cool thing about this too is like any parameters that I have in this get travel time request will automatically be converted to query parameters. Or if it was a post, they would be converted to a post body. And the other nice thing about this too is the status codes I get back from gRPC will automatically be converted to REST status codes. So if I return a gRPC status code, which is a 5 of not found, that'll be converted to a 404 within the REST API. So it does a lot of nice, convenient things for you there. Within the gRPC gateway project, there's tons of examples of these annotations that you add to your proto. And they can get super sophisticated. If you're getting too crazy with them, you're probably doing something wrong. And you should probably step back and ask yourself why you're doing that. Because by default, most things work as they should. But there are lots of detailed examples in this, a bit of everything as part of the gRPC gateway project. So after you've done that, you then run protalk with the protalk gen gRPC gateway plugin. And that'll generate your registration handler, right? So in this case, you can pass in your multiplexer, and this registration function will just register the generated handlers onto your multiplexer, right? And so after you've done that, you can just spin up your Mux server. It'll have the REST endpoints that you have requested to be added. And so you got to ask yourselves, like, why can't we have nice things as Go engineers, right? As a Java engineer for 15 years, the tooling was great, the support was great, the libraries were great. As a father, sometimes I ask myself, why don't I have nice things? And I know the answer. It's 5 children. But we can have nice things, right? And so the other thing is that we can add to this is also Swagger, or otherwise known as Open API documentation. So if you're familiar with that, we'll go over that in detail. But basically, to generate the Swagger documentation for these endpoints, you just add another annotation to your proto, right? So in this case, we add this annotation for the Open API v2 operation. We can add a summary, we can add a description, and all this will be used to generate functional Swagger for us. And so that swagger.json is just a static file that you can then serve up within your gateway to give you functional Swagger documentation. This is just kind of a view of what that will look like. We'll dig into that more with an actual example a little bit later. Okay, the other thing is input validation. How many times have you found yourself just writing boilerplate validation code as you spin up a new web service? You want to make sure that the data coming in is good so you don't have some weird side effect of something going wrong way down deeper in your stack. And so we all know that we should validate our data. There's a really nice plugin that Lyft originally created that then got moved over to the Envoy project. This is the same sort of thing where we basically use annotations in our profile to then generate code that's going to make our lives easier. It supports Go, C++, Java, and Python. And if you were a Java developer at one point, there was these things called preconditions, which is part of Guava. And this is similar to that, but much more rich, I would say. So here's an example of that. So we have this user service. We want to validate that the incoming data when we create a new user is good data. And so in this case, like the username, we have a simple regex, which will validate the format of the username, right? Here we say we want to be alphanumeric, between 3 and 16 characters long. And then we also have an email address. And to validate the email address, this ProTalk library from Lyft actually already has some built-in email validation. So all we have to do is say, give me this validation rule for an email address, and it has to, and by default, they've implemented the validation rules for RFC 1034. Same thing with first name and last name. They have to be at least 1 character. And so just by adding these annotations, it's going to give us everything we need to do this validation without us having to write any of this code, right? It has lots of built-in features around numerics, bools, strings, pretty much any data type you can think of, as well as the well-known types that we talked about earlier. Those are also included in the validation library. So when you run that code generation, you're going to get something like this. It's going to generate a validate method for you for each message that you have validation on. So in this case, we added the validation to the user message. And so we can see here, it's going to validate the username. And if it doesn't validate, it's going to give it, a pretty useful message saying, hey, it didn't match this regex. Same with the email address. If it doesn't validate, we're going to get a message saying the email address didn't validate. And so one thing is it's going to generate this code, but you still have to call it, right? You still have to say user.validate in your code. One thing about the ProTalk Gen Validate project is it is an alpha. So if something breaks on you or the project is no longer supported, don't say I didn't tell you so. But it is, there are active commits to it. There was commits to it just this week. So in putting this all together, basically all of these are different plugins into ProTalk, right? And so as you can see here, the first 2 lines are to generate our client server code. Then we have options for generating our gateway code. And then we have another option here for generating our validation code. So all of that can be done within the same ProTalk command. And then what's cool too is here at the end is when we're generating our Swagger documentation, it's often helpful to have that be combined into a single Swagger documentation. If you're fronting multiple services behind your API gateway, you want that to all be unified with your documentation as well. So there's this option that's part of a gRPC-gateway, which isn't very obvious, but it's this allow merge equals true. I actually had to go look at their PRs to figure out how to use the option properly. But the nice thing about that is it then combines it all into one single Swagger API. So honestly, I put a lot less time into the slides than I did the actual code base. So I want to spend a little time just going over the code base and actually doing a little demo of this so you can see how this all works together. So the first thing is, let me bring up, well, I guess before I do that, are there any questions or anything we want to talk about before we kind of dive into the demo from anybody?
I have one. This is Rob. I don't have my camera on. Yeah. I'd like to know everybody's opinion on the response object. So generally, I at least have a request object. Sometimes I will return back the object, the model instance directly without creating another response object. So let's say that I was getting users. I would have like a get user request, but I don't necessarily create a get user response. I might just return user in that example. So just wanted other people's opinions on that.
That sounds sort of like the kind of the REST-ish concept, right? When you say I want to get users, like some APIs say here's a slice and it's full of users, and others are like here's a object with a user's key. And Rodney, if you're talking, I can't hear you. Sorry. Some other was like here's an object with a user's key, and then inside that is your list of users. And I think it just I see what you're saying. Like I personally like to future-proof my thing and separate. I like to be able to add metadata to a response that is not necessarily user data. So I would err on the side of having a user response, even if it's only got a user key. Yeah, just like kind of Paul's saying, like just because I might want to say like, here's some other stuff that's not about the user itself, but about how I got the user. And you don't have that ability if you're just returning a user. So that's a personal opinion. I don't think you're necessarily wrong. It's just about future-proofing and paranoia.
So on a get user, and we're seeing an example here on get user reply, you would have the user object as part of that reply instead of okay. Gotcha. Thanks.
I don't think you're wrong for doing it, by the way. I think it's mostly because I'm super paranoid and I like having the ability to add extra things. And by decoupling those, you kind of can in the future.
A lot of times I'm working with front-end developers and dealing with REST, and their concern is that it just seems awkward to be between an object with an object inside of it. So
that's fair. That's totally fair. It does feel weird, and most of the time you're right. It's kind of unnecessary. Like get the users list, and inside that is not the list of users, but like I said, an object with the user's key with a list inside that. And it does feel weird, but I think it's all about future-proofing.
Yeah, and we actually had that same issue with our front-end engineer. He's like, why does this say user and then the content instead of just the JSON object when it comes back? And then let's actually look at that. So I'm gonna run my make all command here, which is gonna spin all this up for us. So you can see here we've got the gateway running on port 8081. And then all of these others are gRPC services that are exposed through the gateway. Okay, so here, this is our Swagger page. I'm going to refresh this. So we were talking about that get user endpoint. Before we run the get, I'm just doing like an in-memory map. So let's go ahead and add one. I think a lot of you are probably familiar with OpenAPI, but if you're not, it's super handy. You can actually hit the endpoints using OpenAPI. So here we're going to give it a new user. We'll say, let's see, P. McKay. Why not? Okay. So we're going to input all that information. We'll click execute. You notice it successfully created that. We get back a 200 right here. As far as the validation goes, we're going to see exactly what we expect. If I just put PM in here for the username and click execute, I'm going to get a 400 back. And so you'll notice it automatically mapped this gRPC status code of a 3 over to a 400 on the REST API. And it told me, it doesn't match the regex pattern. Okay, so that's everything we expect to happen. We go to get one of these users back. We type in P. McKay here again, click execute. And this is what I guess Todd was talking about here, right? Is when the response comes back, a lot of front-end engineers are used to seeing just this content here, just the JSON object of just the user. But yeah, I mean, to Carson's point, right? That's not future-proof, right? You can't easily augment that going forward. So this is actually technically better in lots of respects that way.
It's all about metadata, in my opinion, right? Like you can imagine a million things you might add about that user or fetching that user, or that aren't necessarily attributes of the user, but are more related to the call that you just made, and that's where they would belong if you needed to add them in the future. That's my 2 cents.
Yeah, that one's debatable because it's like, okay, I'm retrieving a user. Why would I return anything besides the user? But it is a good argument for front-end engineers when they give you a hard time about that. Okay, so you notice in this API, what's missing? Okay, who can tell me what's missing from these CRUD operations? Oh, GraphQL. Don't even bring up GraphQL here. Okay, what's missing? Delete, Nathan Button, ding, ding, ding. Okay, Paul, get that kid a prize. Okay, so how would we go about adding that? I guess I'm cheating because I have the proto open. What would be the first thing we do? Modify the proto, right? So let's go ahead and do that. So I'm going to be a horrible person here. I'm going to copy and paste the get call and modify it. You guys need to make sure I don't like mess something up here. So we have our remove user function, remove user request. We're going to change that to a reply here. We need to change our get to a delete. You notice I said remove user. It kind of bugged me when people name gRPC functions after like REST terms. Like it's not REST. Like just name it what you want to name it, right? So we're going to change this to a delete. Instead of retrieving an existing user, we're deleting. Use this endpoint to delete users. And okay, that looks good to me. And one thing, okay, so it's giving me some syntax highlighting, tell me we haven't defined these messages yet. On the reply, on a delete, there's no reason to return anything. So we're going to use the well-known type of empty, which just says we're not going to return anything from this function call. The remove user request, we do need to find that. And it's just going to be the same as a get user request. It's not that fancy. It's just the username. So we'll find that. And then that's everything we need in our proto file. I'm going to run the code generation. You can see here I was bad and I didn't Dockerize this yet. But so there I ran the code generation. And so now we need to go implement this new function we just added. So I'm going to go over here to my CMD directory, to my user service. And yeah, I didn't even split these out into a server.go or anything. So so we need to, again, implement this function, right? I'm going to be bad again and copy the get user call just because I'm lazy that way. And it's going to be remove user, which should have a remove user request. And then our reply should be an empty reply. And then, so this is where I was talking about that validate call, right? So here we're making the validate call on the input object. And this is going to run that validation code. And the cool thing about having generated code is you can go read it, right? And with Go, it's very readable code. So we can see the validate call. That looks good. When we're removing a user, if the user doesn't exist, then yeah, let's go ahead and return a code not found. Otherwise, we're just returning empty here. So we need to add our delete. So delete the user. In this case, it's just an in-memory map. So we're just going to delete from our users map. And the key for that map is just in.username. And we're going to return our empty protobuf object. So that should be everything we need to implement the delete. We'll go ahead and run this again. Hopefully we don't have any errors. Yep, looks like we're okay. Our integration test passed. Okay, and then we refresh this page and we see we now have a delete user endpoint. And it's functional. And so that's really the selling point for me, right? I have no desire personally to go write REST endpoints. I would much rather use something that has a really defined contract. And you can see once you have it set up this way, it's super easy to augment, right? You can easily add to your API, extend it, and you can move super fast. Me and the front-end engineer I was working with at the time we put this together, him and I would go back and forth so fast. He would say, I need this new endpoint. I would spin it up, even often just stubbed out, maybe not even fully implemented, and he would start using it like within minutes. And so as long as you've got the right build infrastructure on Jenkins and where, however you're doing your build pipeline, like this can be super fast, allow you to move really, really quickly as a company. And so I guess that's all I had to present. Thanks for listening, and maybe we can have some questions, any discussion you guys might want to have.
Any questions? I know we have more.
Tell me the bad stuff. What sucks about gRPC?
It doesn't work with curl.
Hey, well, hold on a second. Okay.
gcurl, Greg Bray. gcurl.
No, it's
Which is
called
never on the system I'm on when I
gRPC-curl
need
was
to
written
troubleshoot.
by what's its space. You can use Jason's Postman tool. gRP-curl by Full Story. I've used it. It's great.
No, that's a good
Yeah.
point, right? gRPC is not readable. So what have you guys used? gRPC curl? What else?
Yeah, because it's a little higher up and a little more complex on the stack, you do lose some visibility into it if you're in a deep dark corner and you can't TCP dump your way out of it. You gotta get a new set of tools.
Kubernetes load balancing is broken by gRPC if you're not careful, because they got persistent long-lived connections. So your service load balancing and distributing and like adding more pods may that actually give you more capacity.
Everything in gRPC is broken when you're using like an HTTP based technology like load balancing.
Yeah.
Scrubs. No, that's true. We ran into that recently with somebody else's gRPC for a service that we were trying to run. And it's like AWS barely added the ability to understand gRPC exists, and none of the things work nicely like load balancing. So you are absolutely correct.
Yeah, and one really handy tool as far as like being able to visualize. Well, okay, if you're on the server, you're kind of screwed, I guess, especially if you're in a Docker container with no tools on it. But I guess, Carson, I'm curious, what do you do for the load balancing?
Oh man, so there's a lot of Kubernetes articles out there about like gRPC and how to do it. A lot of it is like some of the cheap ways are you just turn on DNS based round robin for your services, and you lose some of your persistent connection, benefits by just sort of emulating and saying, well, for all your calls, you need to, constantly be looking up gRPC endpoints and switching around. So that's pretty much how we've done it in all of our current. In fact, I'm almost positive that's the default in the clients that we generate internally in Weave, is that like even if you don't know you're doing it at Weave that way, that's how you're doing it, because we're not trying to resolve for that. I think some of the service meshy things are starting to support that natively, but the whole Kubernetes construct really isn't built around persistent connections and how you solve some of that.
Yeah, and
Does Envoy solve the problem?
Envoy has filters for it. It's the nice thing about picking gRPC is it does have enough momentum that it's starting to make its way into all the places. Having been at a place before that picked a binary protocol that is not as popular, it's even more painful because you wouldn't have options like Envoy and an army of people helping. So you do kind of buy into the ecosystem, and if you're really big on some part of it, and you either have to build it yourself and bring it, or hope that somebody else has done that, and that's not the case with other transports always. Like it's why you would choose gRPC instead of rolling your own or picking an older one like SOAP or something that's even more archaic.
How dare you mention that here?
Most of the time you want to, like, scaling's, we all love to think about it first, but it's often the thing you shouldn't be thinking about first for most services. You should be thinking about other things around your services rather than like happens when I do a billion of these, because most services don't get there most of the time, I feel like, and I fall into the trap all the time. Like there was some article I read recently, someone was like, oh yes, the best way to destroy like an entire conversation with an engineer is to bring up scaling. Over engineering things. So I don't think it's a big deal. It is a big deal in Kubernetes in very specific contexts, like when all of your pods go down. So you have 10 pods that are gRPC that are backed, that are backed by a gRPC service, and 9 of them shut down, but 1 stays up. All your clients are going to naturally reconnect to the one that stayed up, and when your other ones scale back out, they're not going to redistribute. And I think that's actually more of a risk than I need to add a lot more of these and dynamically distribute. So, but honestly, us moving to, we're going to do round robin and kind of not do the persistent connections most of the time is a cheap way to solve it.
Hey, Jeff, quick question.
Yeah.
For secured connections, how are you dealing with cert management?
So with cert management, so the nice thing is, right, when you expose the API gateway, right, you're exposing it via your traditional MUX router, right? So you can do anything you want there, right? You can do any way you're doing your cert management today, whether that be at the load balancer, whether or not you're going all the way down to the pod, right? Completely up to you, right? But you have, that's the nice thing, is you have full control over that. And I'm actually curious if any folks here have run into these issues where you see yourself translating between REST and gRPC, or how you guys are solving some of these problems today. Any of you are using gRPC-gateway or other solutions? I know like Envoy has a gRPC JSON transcoder. I'd be curious to see if anybody's using that. Yeah, I mean, this definitely isn't the only way to solve some of these problems.
Yeah, when I was at Reddit and they were trying to make inroads into gRPC, they were looking at transpiling the calls, because once you make a decision and you just have it throughout your entire code base, it's a lot easier to just be like, yeah, it's not the greatest, but if we have a sidecar that talks the thing we want and then converts it into the thing that everybody else is using, sometimes that's a very valid approach.
So
What about versioning? Oh, go ahead.
Sorry, my name is Joseph. It's been a couple of years since I've been to one of these, but gRPC is actually something that we're using where I'm currently at right now. And one of the problems we've run into, the gentleman talking about certs made me remember it. We're trying to instantiate authentication, and obviously, as you know, authentication has to have both the server and client instances have to have certs in order to have that. So you have that transport level security. So I'm actually curious, like right now, basically, my manager was like, roll your own cert for now, right? And we'll just use it. But like, what do you do with all of those? Because that is kind of a unique restriction that gRPC has for authentication. Like normally, like in REST, you can have a client which isn't verified by an SSL cert that can talk to a server that is. So it is both parties have to have one, and that's a little bit of a different paradigm.
I mean, there are
curious if people get around it.
Yeah, you're specifically like you're drilling into mutual TLS and the fact that gRPC is going to try to push that really hard for you as a requirement, and traditional REST clients don't.
Yeah.
Like you could solve for mutual TLS for your regular, REST clients, and people do. It is tricky. I think if you have some advantages if you're in things like Kubernetes, it's a lot easier to use something like CertGen or Cert Manager and just do cert generation that's kind of built onto your platform for you. You can even do that with some of the clouds, because if you have a lot of services and you're right, if you want to gen certificates for everybody and distribute it around so that both client and server can validate each other, if you don't have a larger platform in which to do that, it can be really, really tricky.
Yeah. Yeah, that absolutely makes sense. Right now, all of our stuff is, I hate it, but it's all self-hosted. So we don't, you're right, we don't have the advantages of some of the really good tools. Like the one I think of is ACM, Amazon Certificate Manager, right? Where you can provision private certificates. But yeah, we don't have that. So we're like, I guess we're rolling our own. I'm just curious how people got
Even
around it.
on-prem, you can use things like SaltStack and some of these other provisioning tools. Or Terraform can do certificate generation and handle that. I think anything
Cool.
that's not just running CFSSL or open an SSL commands yourself is probably valid.
Gotcha. Cool. I will. Yeah, I'll have to do some more poking around. So
If you're trying to like solve this, I would really recommend look into Terraform or SaltStack or Ansible or one of those to generate all your certs and inject them onto your instances for you.
Cool. Yeah. Well, one of the other things is we don't have the opportunity of, we don't have control over our own build pipelines or dev environment. Going through DevOps is this massive process, but yes, that is absolutely a great path to go down. So
Yeah, and I think Joseph, there's some more links that folks posted in the chat there in case you didn't see them.
perfect.
Okay, what else? Anything
Versioning.
else? Versioning.
Versioning.
Don't break things.
Yeah, that's nice. So back for us in reality. Do you version your APIs, or just not? Are you kicking that can down the road and hoping the community will solve it?
Yeah. So one thing I did, I mean, you might have seen it in the proto. It did have a V1 in there. One thing we're starting to gravitate towards is the buff style guide. I don't know if you've looked at that for gRPC. The buff style guide, it specifically addresses versioning in there. And I mean, it's mostly kind of V1, V2 versioning of your gRPC version, specifically of the service. I don't know though. I'm not sure if I'm fully convinced personally, right? Like I've never found a case where I can't maintain compatibility. I've yet to find that case. But
you were a Java engineer for 15 years. Did you not work with any enterprises or anything?
Well, I worked with lots of APIs that were versioned and were a pain. I mean, like Google, for example, they would sunset their API and you had no choice but to move to the next version, right? And they did not care about backwards compatibility at all, right?
Yeah.
But, I guess, sorry, within the scope of Go.
In your nice place, yes.
But there are times though, even at Weave, right, where we've spun up a V2 version of our gRPC API and we've migrated to it. But I don't know. I think it's more rare than people think it is. People seem to think we always need versioning. But there's no reason you can't, in your initial version of your proto, put it as a V1. And if you always stay at V1, fine, right? But at least you have the capability to move to V2 if you start that way. So I do think the buff style guide of starting with a V1, and maybe you always stay at V1, maybe at some point you move to V2, but at least you have that flexibility.
My limited experience prototyping is that, yes, stick with the V1 and hope it lasts forever or whatever. But then the moment you have to switch to a V2, because that's what the prototype was, is how do we version this? You have a combinatorics problem where you have to then version everything else underneath it. So like you have to have a difference in your gRPC gateway, whether you're doing the JSON gRPC gateway translation thing, you have to version individual APIs if you're doing that route. Like it depends on your choices what it all affects, but it is kind of an explosion. And one of our frustrations with gRPC at the moment, not that there aren't enough great things to add to it as well. There's always problems, but I like to weigh those costs with the benefits too. I was hoping somebody would have a clever solution like, oh, that makes my life easier.
Well, I would say, if you haven't already watched Johan's talk that he gave at GopherCon UK on gRPC Gateway, go watch that because he does talk about versioning on the gateway in that talk.
Did you say GopherCon? He gave that at Go West?
He gave it twice, yeah.
No, I thought he only gave the Postgres one at GopherCon.
No, the one, if you look at the GitHub page for gRPC Gateway, it has his GopherCon UK talk on there.
Oh, UK.
The critical takeaway.
Gotcha.
The critical takeaway is to watch the Go West version, right?
Either one. I
Oh,
think
wait,
the
hold
Go
on.
for Con UK is
Hold on.
longer. Hey, Jeff's wearing the Go West shirt because he likes me.
Yeah. Can't believe I didn't have that zipped down. Sorry, Mariah.
It's okay. It's okay. And with that, I'm gonna go ahead. Thank Jeff. We'll do our silent applause for Jeff because we don't have microphones unmuted, right? He seriously has been talking about gRPC Gateway since he started working at Weave. So that's been like, what, 18 months, Jeff, that you've been talking about gRPC Gateway? So it's awesome.